assessment wherein every time there's a typhoon that enters the Philippine area of responsibility, everybody meets up. No? All agencies concerned with disasters meet up and they discuss. And the reason why they discuss is because they want to prepare for the incoming hazards. And they know that the warnings that should be given are the warnings that are hazard-specific, area-focused, and time-bound. So the way they used it was, okay, for example, when they see that it's raining in a certain place and the water level increases, you can alarm the people. So water level that is recorded without any rain is actually more or less at a certain height. No? But when there's a severe weather disturbance, it goes up, and then when it suddenly goes up, that's when the disaster strikes. The trick to avoid the disaster is to catch the water level while it's on the rise. No? So if you have sensors that give you an idea of where it's raining, and then you look at the water level sensor from upstream, you know that you have at least about 3 to 6 hours, sometimes 12 hours lead time to evacuate. And that was used in the past, no? In PIDRA, to provide hazard-specific, area-focused, and time-bound warnings. And when the DRRM officer was called at around 12 o'clock, peak floods happened at 6:10. So there was a lead time. And before the peak floods happened, the DRRM officer and the local government unit was already able to take them away from the hazards. So just to explain further how to do that warning. So for example, from the sensors, there's a record of rainfall. Now it's colored. The term is contouring. No? From the sensor record, you contour. It's yellow there, it's blue. Yellow means 300 to 400 millimeters of rain. In the UK, when they talk about 100 millimeters of rain, that's the type of rain that will cause a flood and will devastate an entire village. That's in the UK. But during Habagat in 2012, in 2013, we had rainfall in Metro Manila that reached about 1,063 millimeters. 10 times more than what the British people fear. So we are actually, in some way, resilient. This one is 300. No? So it as shown in that color, the scale says 300 to 400. So if it rains in the mountains, the water will not all seep through the ground. Some will run off on the surface. And when they run off, they enter into streams, enter into rivers, okay, and eventually end up into the sea. Okay? So if the community is here, vegan is there. If the community is here and you record rainfall at a certain instance to be more than 100 millimeters, in this case 300 to 400 millimeters, you have enough time to avoid the flood which will come 4 to 6 hours later. Okay? And that is the use of technology. No? It's called as an early warning system. And we need to put that in place because if we don't put that in place, then there's no warning system. If there's no warning system, we are caught unaware. Another case happened in Cagayan de Oro. This was on December 4, 2012. So this sensor recorded rainfall that caused the river to go up. No? From this level, from 1 meter to 8 meters in the span of 1 hour. 1 hour tumaas ng 8 meters. Do you know how high 8 meters is? That's 2 floors. Where else will that water go? But to the sea. And before it reaches the sea, it will have to pass through Cagayan de Oro, which was devastated a year earlier in 2011. But despite the high water levels and the floods rushing in very quickly, it's called as a flash flood. By the time it came rushing towards Cagayan de Oro, they were already warned because of technology. There was an early warning system. And when the floods came rushing in, all of the people were just in the hills trying to view that hazard event. So these are the landslides, okay, mga disasters that happened. Ever since nagkaroon ng Project NOAA, these are disasters that happened, disasters that were averted. But up to Vinta, no? But there were also some that happened, no, after 2012, like the Pablo landslide, like the storm surge of Haiyan, and these Urduha and Vinta tropical storms that devastated many towns in Biliran, as well as Mindanao, respectively. In avoiding disasters, there are two key elements: warning and response. Warning is the responsibility of government. It must be accurate, reliable, timely, and understandable. Okay? But no amount of good warning or accurate warning will work if you don't take action. Diba? O, nag-warning dun sa, ano bang tawag dun sa, ano na yun, yung app na yun, yung meron kayong emergency alert. O, winarning kayo, did you take action? Did you, yung 3 o'clock, tumindig ka ba, o tinignan mo lang kung may baha sa labas? Hindi ba? Tama. O, so, may warning, but you didn't even bother to stand up. Correct? Am I correct? No. Did you hear that alarm? No. You don't have a cell phone? Meron. Nokia. So, you didn't even bother. So, what about the others? Diba? So, with a warning, which is the responsibility of government, there must be corresponding appropriate response, which is your response. And your response must be appropriate. Not responding, sleeping, and being warned, not even bothering to look outside, that's not appropriate. But sometimes, if you do that, sometimes people evacuate. But you need maps to tell you where to evacuate. Yeah? And sometimes people go to evacuation centers that are the places where they die. Okay? So maps are very important. Like for example, in Tacloban, there was a storm surge warning 2 days in advance. 2 days in advance. But the maps that were provided to them 2 years before, which was used by the LGU, showed the storm surge inundation of the coastal area here, 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 here. Wala dito, wala dito, wala dyan. Okay pala dun eh. Oh, may storm surge, pero hindi naman pala babahay. Lagay natin evacuation center dito. Kung saan nakaturo yung this map is called as a deterministic map. The one to your left. Aba? Left. And it's based on interviews. So, interviewing kita. Nagkaroon na ba ng storm surge dito? Gano'ng kataas? Hanggang dito lang. Hindi umabot dito. Wala dito ang storm surge. And they make it into a map. So, it's based on the experience of the community. Not that I'm saying that it's not good data, but it's probably not sufficient. It's necessary to collect the data from the people, but it's not sufficient. Because what happened during Yolanda was an event that was bigger than what they remember. Correct? Because this was a bigger event than what they knew. And therefore, they were caught off guard. They were surprised. Pag marami na surprise, anong mangyayari? No. Diba? What we needed before Yolanda struck was a kind of map called as a probabilistic hazard map. It's multi-scenario. It depicts the small storm surge, the big storm surges, the bigger ones, and the Yolanda type storm surge. And had we had this kind of map, a probabilistic hazard map, before Yolanda came, we could have advised all of those people who went to evacuation centers. Or we could have advised people to move away 2 to 3 kilometers away from the coastline. But we did not have those. So the warning gave an absolute value of the height but did not give the inundation extent, the inland inundation. It was a warning of an absolute height in a relative landscape. Okay? So we need these kinds of maps. We didn't have it kasi wala tayong technology at that time when it happened. But now we do have it. No? We invested billions of pesos to get the technology, yung LiDAR, and to train young scientists to do the manual work, to run these simulations, to create this kind of maps that would tell us, that could have told us that these places are dangerous. And 80%, 70 to 80% of the evacuation centers got inundated by storm surges. Hundreds of people died in those evacuation centers. I'll give you another example. This is a deterministic map, single scenario, based on interviews. Sabi, yellow refers to low susceptibility to landslide. This is an official map, by the way. So let's put the evacuation center here because amongst all of the places, that's the lowest hazardous area, the lowest susceptibility to hazards. Let's put the evacuation center there. But of course, after the disaster, after it happened, many people died in that place, Barangay Andap. The map was changed because it already happened. It's part of the historical record already. So it got transformed into high susceptibility to flooding. Okay, this is Barangay Andap, that one. You can see that the river flows here. It's a small river, relatively small river. So when the people were transferred to that place as an evacuation site, sabi, that river does not really become big. No? It's just like that. We can stay here. This is a safe place. It lacked science. Kasi the science and the technology would have shown that that place was dangerous. But science was not used. The technology was not used. What happened was, when Typhoon Bofa came in, it rained, and then it generated this big debris flow, a flood. It's like a flood, but instead of water, it was 80% boulders, 20% rocks. So it overwhelmed Barangay Andap. Each of these dots here, the gray and white dots, these are rocks. Yan. Sometimes as big as that. 3 meters below that man is the evacuation center, where 566 people died. They went to the evacuation center. They were warned. That's why they went to the evacuation center. But what happened? The response was not appropriate. They went to the wrong place. Because the hazard map that was used did not reflect the bigger event than what they knew or than what they remembered. So, the lesson there is that when we make maps that are supplemented by science and technology. Local knowledge is good. It's necessary but not sufficient. We must supplement it with science and technology to depict hazards of the future, to depict climate change impacts. When we talk about probabilistic maps, it's multi-scenario as opposed to single scenario. And in the Philippine practice, yung single scenario natin is the scenario that is what is the worst that is remembered by the community. But what if it is bigger than what the community remembers? Diba? So we need multi-hazard, multi-scenario maps. These are called probabilistic maps. So we have a storm surge that is small, a storm surge that is bigger, storm surge that is much bigger, landslide, storm surge Gayulanda, that was landslides, then floods that are small, bigger, and then we put them together. You have a multi-scenario, multi-hazard map, probabilistic hazard maps. And despite that, na puro pula, ang dami pa rin mga areas that are safe, those in gray. Okay? That's where you cite the evacuation center. Not in the red place. But you will not see that safe or dangerous areas if we don't use the technology and if we don't use the science. And because of our investment, we are now able to do that. So this is interview-based, no? This is low landslide, this is high landslide, low flood. That's the deterministic. Pagka gumamit kayo ng probabilistic, you make a good depiction of the landscape at high resolution. You are able to know the elevation. You can plot all of the elements in that area, even the land use map, and you can show a small flood, a bigger flood, a much bigger flood. No? So, multi-scenario pag sinabing probabilistic. Bigger scenarios as well than what the community knows. Okay? So, for development planning, that's very important. Kasi the interview-based one will tell that community or the planner, or let's put the evacuation center here or the school there. Diba? Kasi that's, the people in the community remember that it does not flood in that area. Pag mas malaki na yung ilan, a bigger event than what has happened in the past, you are going to kill all of them. Tama? And that can only be shown using advanced technologies. That can only be depicted if you use advanced technologies, okay, which makes use of science, our understanding on the physics of flow of water and stability of rocks in the case of landslides. We have been doing local climate change action plans for all communities. Okay? Ang daming communities. This is their land use plan. You can put the flood, the storm surge, the landslide hazards, and their land use, their planning. Put them all together, and you can see the plans in relation to hazards. Okay? So, ito yung settlement area. It has a hazard. Okay ba dyan magplano ng settlement? How about this settlement area? Is it good? Yes, di ba? So, you don't need to imagine. You can already visualize and see where the dangerous and where the safe places are. Correct? Okay. So, in planning for settlement in a particular community, that's what you choose. And you chose that because the information was made available. And it's very clear. For agriculture, okay, binabaha nga itong area na ito in some parts but not all parts. Then, let's plant in the non-flood prone areas. But for flood-prone areas, for climate change, we plant crops that are resilient to floods. Diba? And for tourism, no? So, Calao Viewing Center. This is an actual example. No? It's a municipality in Leyte. It's a bird viewing center. It's dangerous, sinasabi. It's very dangerous. Landslides due to heavy rainfall may happen there anytime. But we know that the storms don't come in every day. Diba? Don't pass through every day. It's about 2 to 3 times in a year, sometimes 5. So what you do is you plan for an evacuation center there, no? A backup center. So pack up when there's a storm, and when it's in the South China Sea, pag nag-exit na, go back, business as usual at the shortest possible time. That's how you plan communities. And when you plan it, you don't just plan it for settlement and agriculture and for tourism. You plan it for agriculture, coastal water, health, forestry, biodiversity, the environment, energy, education, tourism, infrastructure, settlement, and mining sectors. Imagine if you can plan a community and all communities of the country and plan it across all sectors, doing anticipatory planning, there will be true and real development of each and every municipality of our country. Diba? Kasi they will progress unhampered by the impacts of hazards. Don't be intimidated by this graph. No? This is just accumulated rainfall per day. This is the frequency. No? So once every 100, yung, for example, 280 millimeters of rain as recorded by Pag-asa. This is the historical record of Pag-asa, the black line. But we've heard about climate change. And sinabi sa climate change, if there's going to be impacts of global warming, one of those impacts will be more intense cyclones, bringing more rain. So there are projections and these can be modeled. So yung dating 280 millimeters of rain, when you project it to a climate change scenario ng 2049 or a climate change scenario by 2079, yung dating 280 millimeters that happens once every 100 years becomes more frequent. Mas mararanasan natin yan, it's going to be once every 12.5 years. So with climate change, ano mas mangyayari? Mas lalaki yung problema natin. Not only in scale, but in frequency as well. Diba? Mas mahirap yun, ha? Madalas mangyayari yan. So we have to handle it more frequently. We have to deal with it more frequently. Sabi din sa climate change, yung dating once every 100 years, na pagka once every 100 years, imbis na 280, magiging 400 millimeters. Dami yung ulan. Pero how do you translate that into planning? So, I give that knowledge of 280 na once every 100, magiging 400. You're the municipal planner. You're the architect. You're the urban planner. Binigay ko sa inyo, 280 magiging 400. Oy, thank you ha. Salamat, dami yung ulan. Okay. But what will you do with that information? How can you plan against the hazards? The rain is not the hazard. May nakita na ba kayo na ulanan na namatay? Naambunan o kaya nabuhusan kahit malakas na namatay? Have you seen one? So is rain the hazard? Hindi, di ba? We must plan against the hazard. So somebody must translate that increase in rainfall into a map like this. Di ba? That when translated, yung rain into a flood, you can see the river and the floodplains inundated. And what height of flood will happen. And you can see that this subdivision is okay, but this subdivision is not when that climate change event happens, na extreme rainfall. This place is dangerous. But these places are good, even with increased rainfall due to climate change. Tama? So, we may want to think that preparing for hazards na historical rainfall, yung alam natin, no? Yung na-record ng Pag-asa, yan yung rainfall. Preparing for the impacts of rainfall that will transform into floods as disaster risk reduction. Correct? Kasi, alam mo na yung flood eh. Alam mo yung rain, this will bring a flood. You prepare for this historical record. It's DRR, disaster risk reduction. But, if you prepare for rains that are projected into the future, bigger events of the future, due to climate change, you are doing preparation for future disasters, but with climate change impacts. And to address those future disasters, you need to plan well. You need to adapt to the climate change impacts. And it's called climate change adaptation. But since you're dealing with disasters as well, natural hazards, you call it climate change adaptation, disaster risk reduction. If we plan each and every community against the hazards, against climate change impacts, across all sectors, we do anticipatory planning. We are developing that community away from hazards, away from disasters, unhampered by natural disasters or natural hazards. If we do that for all 1,634 municipalities of the Philippines, we not only develop each and every community, we get them free from disasters, and they develop, they progress. And if all of these municipalities progress, our country develops, our country progresses. Don't you like that? Don't you like that? Without being the president, you can get the country to develop. Would you like to be part of that effort? Wouldn't you like the Philippines to be great and develop? We use the disaster platform, we use that bill to develop our country using probabilistic hazard maps and probabilistic risk assessment and local climate change action plans. we make use of this concept, reverse it, make that disaster platform work for our country and make our country develop using science. Thank you.